So far, what we have graphed in this course are linear functions, meaning functions that will graph as a line. Now, yesterday we talked about the fact that there are obviously nonlinear functions, and what we want to do today is identify uh, equations that will tell us that we have a nonlinear function. And then in addition, we want to graph some basic nonlinear functions. Okay, so if we read the guided notes, to date we have graphed equations such as y equals x plus 2 and y equals 1 half x minus 8. These are called linear equations because they graph as lines. In addition, the variables x and y are raised to the first power. Right? In a quadratic equation, the greatest power of the variable x or y is 2. So now one of our variables will be squared. The graph of a quadratic equation is a curved figure called a parabola. The standard form of a quadratic equation is y equals ax squared plus bx plus c. So now, instead of our y equals mx plus b form, what we have here is we have the variable x being squared as an attachment to our formula. So if you think of bx plus c like our mx plus b concept, but now we're attaching that. All right, so very simply what we want to do is what's a, b, and c in this quadratic equation? Well, a is the variable in front of x squared, 2. B is the variable in front of the x, which is negative 5. C is the constant, which has no variable. Now, as we mentioned, a parabola is a U-shaped figure, or curved figure. And what it looks like is a figure opening like that, or like that. Okay? We can very simply tell if it's going to open what we say here upward or open downward by examining A. If A is positive, then the parabola opens upward. And converse, if A is negative, then the parabola opens downward. Okay? Now, we'll see that in a moment when we do some graphing. So let's do some very simple examples here. Okay. We want to graph the following quadratic equation. Y equals x squared. And I'm going to give you the values to use. Let me just, okay. All right. So what we're going to do here to graph is what we've previously done is use a table of values. There's no shortcut here like there is with finding the y-intercept and the slope. So when x is negative 2, y is 4. When x is negative 1, y is 1, 0, 1, and 4. Now, what you'll notice here is that what happens is I now have, and I'm just going to orient this as I talk, you'll notice in your y column that you have values that are repeating. In other words, the 4 and the 1 both repeat. And my board is not cooperating. Let's see. And you'll see how that works when we do our graphing. All right, there we go. Sorry about that. Okay, well, let me just get rid of the keyboard. So now when I graph using this table of values, at negative 2, I have 4. At negative 1, I have 1. 0, 0. And what you'll see is I need the repetitive y values so everybody has a matching partner. So you'll see here I have matching partner on each side. Here I have a matching partner on each side. That gives me the symmetrical look to my parabola. Okay. Now, at the bottom, I want to graph y equals x squared plus 3. I'll do this in green. So when I do this, when I plug in -2, I get 7. -1, I get 4. 0, I get 3. I'm going to get 4 again. I'm going to get 7. One of the things you got to get into the habit of looking for is this repetitive values on the y side. Okay? So now I'm going to graph this. And what has happened? The shape is the same shape, but what we've done is by adding 3 to the second equation, the parabola translated 3 units up. Okay? So all that did was translate the parabola like we've seen before. What would happen if you subtracted 3? Well, then you would translate the parabola by moving it down 3 units. Right? Now, we want to take a look at what happens when we square. Again, I'm putting the not square but multiply by a value. So I'm doing this again only because I want you to be able to visually see how the parabola changes. So blue is my original. Now, I'm going to multiply everything by 2. So that becomes 8. That becomes 2. That's still 0. That's 2. And then that's 8. So when I graph this, I get -2, 8, -1, 2. Still say 0, 0. Now, interestingly enough, what happened to my parabola? Well, hopefully you'll notice that when I multiplied it by 2, in the second equation, A is 2, which caused the parabola to contract or get compressed. What do you think would happen if I multiply by 1/2? Hopefully you would then realize that the parabola would expand. A little bit counterintuitive to what you've seen with dilations, but that's because of the way the math works with the numbers, with them. Okay? So what we covered today, again, is just some of the basics on graphing quadratic functions.